Hi students, in this video we will discuss about pointers, that is introduction to pointers. Now before discussing pointers, let us discuss initially some of the known concepts and very important for pointers. So in order to understand the pointers, we need to know two things. One is ampersand. Earlier in every program in a scanf function we used ampersand. What is the purpose of ampersand? This ampersand gives address of the variable. Ampersand gives address of the variable, and asterisk symbol. So we use in pointers asterisk. So asterisk gives value at the address. So this asterisk symbol can be applied only on addresses. Ampersand is used to get the address. Asterisk is used to get the value at the address. Okay, now I will show you with example these two concepts. These are very important. If you understand this, then only we can understand pointers. Now first, I have declared a variable called int a equal to 10. Now tell me what happens when we declare a equal to 10. So till now we discussed that with the name a it will allocate 4 bytes of memory. Let us, and 10 will be stored in a, we have discussed till now. So it will allocate 4 bytes of memory, we are saying. So what is the address of that memory location? We will be discussing in pointers about the address of the memory location. Now let us assume that it will occupy 4 bytes. Let us assume that the starting address is 1000. Let us assume the starting address is 1000. Here a is the name of the memory location, and 10 is the value of the memory location, and we are assuming that system will allocate different address. We are assuming that for explanation purpose 1000 is the address, so it will allocate 4 bytes. So what are the 4 bytes? 1000, 1001, 1002, 1003. This 4 bytes memory will be allocated for a. Now let us focus on these 2 points. Int a, printf a, it displays 10 onto the screen. Now in order to display the address, for displaying address we use two format specifiers. One is %u can be used because address is always a unsigned int. So we can use %u, or we can use %p, which displays in hexadecimal format, or we can use %x, either small x or capital X we can use. So this will give you the numeric value. These two, or capital X, will give you the hexadecimal format. This gives you the value in address will be displayed in hexadecimal format. Generally in most of the application I will be using %u while explaining. If you want, you can use even %p or %x. Now printf a, so it displays a value of a. What is that? 10 will be displayed onto the screen. Now I want to display printf ampersand a. What is ampersand a? We call it as address of a. Then ampersand a, it displays the address of a. Whatever the address the system allocates, now we can see on the screen that address will be displayed. Generally till now we used ampersand in scanf. Now we are using in even in printf. It gives, we are assuming 1000, but internally system will allocate different address. That address will be displayed on screen. Now let us see the output. Okay, return 1 and with semicolon. So save, compile and run the program. So what is the address it is displaying? 64,87,580. Now let us assume that. So what is the address? So 64 lakhs 75,000 something. uh, 57, what is the address? So 7580 something, some address it is displaying. Okay, so the same address will be displayed, that is ampersand a will give you, run once again, this is the address. So 64 lakhs 87,580. Okay, now here 64 lakhs 87,000, let us assume that, actually we assume 1000, internally it has allocated this address. So for you people it may allocate the same address or different address, there is no guarantee what address it will allocate. Okay, now that is ampersand a gives you the address of the variable. Now print f star of ampersand a. Now this is very important to understand. Star of ampersand a, star of ampersand a, and with semicolon. Now right, star of ampersand a, this is very important. What is star? Value at the address I told. Here first star of ampersand a means first solve, get the value of ampersand a. What is ampersand a? Address of a. According to our program we are assuming address is 1000. Star 1000, star 1000, what is star 1000? Value at address. 1000 is address we are assuming, that is value at 1000. What is the value at 1000? 10. This statement will display 10. A will display 10 and ampersand a will display the address which has been allocated. Star of ampersand a, it gives you the address. This asterisk symbol represents value at the address. Okay, now let us run this program. Okay, a ampersand a, you should read it as address of a, star ampersand a, we should read it value at this address, that is 10. Now let us discuss, I hope you have understood about ampersand and asterisk. Ampersand gives address of the variable and asterisk gives value at the address. Okay, now the very important point, what is a pointer and why a pointer is used? Here we can call a pointer is a special type of variable which stores the address of the variable of same data type. Same data type. So what is a pointer? A pointer is a variable which stores, a pointer is a variable which stores the address of the variable of same data type. Meaning of this is, integer pointer will store the address of integer variable, float pointer will store the address of float variable, double pointer will store the address of double pointer. Now here we can say why, what is the need of storing the address? By storing address we can achieve the concepts like, one is call by reference. Call by reference. Call by reference meaning if you make any changes in one function, it will affect other functions. That is, the value, the data of one function can be accessible from other functions. Even C language has become popular only because of these pointers. Before C there were many languages. In other languages there were the concepts of all other concepts of C except pointers. C has introduced the concept of pointers. So using pointers we can achieve call by reference as well as dynamic memory allocation. We can achieve these two things in using pointers in C language. When we go to data structures, in every case you will be using the pointers concept. Now how to declare a pointer? Pointer declaration. Can we declare it like a normal? Yes, we can declare like a normal variable. The syntax here is data type asterisk pointer variable name. Here at the time of declaration, that is while declaring the data type point star variable name, that is the name of the variable must precede with asterisk symbol, then it is treated as pointer. Example, here you can see int star p, we call it as a integer pointer. Integer pointer, that is it will store the address of integer variable. Char star q, we call it as a character pointer, it will store the address of character variable. So pointer will store only addresses, pointer will not store values. Remember these points. So at the time of declaration, if we use this star, we call it as a pointer. So pointers can store only address, pointer will not store values. That too, a pointer can store the address of similar data type. That is, integer pointer will store the address of integer variable and character pointer will store the address of character variable. Now, why pointers are used? Using pointers, we can achieve call by reference, dynamic memory allocation. Now, let us see the same example. Now here I have declared one variable called int a equal to 10 and I am declaring another variable called pointer variable int star p. This is a pointer. Which type of pointer? Integer pointer. Now let us see what happens. Int a equal to 10. Now let us assume that with the name a, it will allocate 4 bytes of memory. Let us assume that its address is 1000. Then 10 is the value of that variable. Then int star p. What is star p? Pointer variable. Now here we have a declared even pointer. Memory will be allocated even for a pointer variable. Now let us assume that the address of this pointer variable is 2000. So here this 1000 and 2000 for explanation purpose I am using. Internally it will allocate other address. Different address will be allocated. Now so p equal to a. So here this is not possible because we cannot assign value to the pointer. We can assign only address. Okay. So I am removing this part. So p equal to ampersand a. What we are doing here? So address of a is assigned to p. So what happens here? So this pointer will stores the address of a, that is pointer is holding the address of, that is 1000 will be stored in p's memory location. Now the first example, this one using pointers, very important one. So printf a equal to percentage d comma a, that is value of a. What it will display? 10 will be displayed onto the screen. Similarly printf p equal to percentage u slash n comma p. What it will display? Displays, this statement displays 10 and this statement displays, that is value of p. What is that? Value of p. What is that? 1000. We are assuming 1000. Internally whatever the address it has allocated, that address will be displayed. Now let us see, save, compile and run the program. So 64,000, sorry, 64 lakhs 87,572. So here what is in place of 1000? What is the address it is allocating? 64 lakhs 87,572. Okay, wherever we are saying 1000, it will display this address. Okay, now let us say This is A is 10, this is 1000. Now print f ampersand A. What is ampersand A? Address of A. What is the address of A? We assume that it has 1000, but it will display internally 64,87,572. Then similarly printf ampersand P. What is ampersand P? Same, address of P. Ampersand A means address of A. Ampersand P means address of P. That is ampersand P. Now save your program, compile and run the program. Now you can see here the address of ampersand A is 67,580 it has allocated. Ampersand P means so 64,87,568. Now here different address has been allocated. So ampersand A, that is address of A, ampersand B, address of ampersand P, address of P will be displayed onto the screen. Here it displays address of A, that is 1000, and here it is address of P, that is 2000. Internally whatever the address it will allocate, that address will be displayed. Now let us concentrate on printf star of ampersand A equal to percentage D slash n comma star of ampersand A. Now so that is star of ampersand A. In the last program we have seen, that is value at address, that is value at 1000. What is that? Value at 1000. What is that? 10. 10 will be displayed. Now similarly I will use printf star P equal to percentage D slash n comma star P. So what is star P? Only P means 1000, value at 1000, that is also 10. So both these you can see last two outputs will be 10 and 10. Save this program, compile and run the program. It is displaying 10 and 10 onto the screen. Now similarly we can say printf star of ampersand P equal to percentage U slash n comma star of ampersand P, then end with semicolon. Now let us check what is ampersand P. 2000. Star 2000 is value at 2000. What is the value at 2000? 1000. This statement will display 1000 or address of A. Displays address ADDR, address of A will be displayed. According to our example, it is 1000. Next similarly printf star star ampersand P equal to percentage D slash n comma star star ampersand P. Save this program, what it will display. So here if you observe carefully, ampersand P gives you address of P. What is that? 2000. Star 2000 is 1000. Value at 2000, 1000. Then again take this star 1000. What is star 1000? Value at 1000. What is the value at 1000? 10. So this statement gives you the value 10. Now save your program, compile and run the program. So here you can see star of ampersand P, this is the address of A, and star star ampersand P, value at that particular address. Now so this is one concept we have seen. Now let us focus on another important concept. Please, if you have any doubts, please comment. Now let us focus on this part. A equal to 10 into star P, it is a pointer variable, and P equal to ampersand A. It is p equal to ampersand a holding the address of a. Printf a 10, printf p 1000 will be displayed. Now I will write a plus plus. Tell me what happens. A plus plus printf a equal to percentage d slash n comma a. So a plus plus means it increases the value of the variable by 1. 1 will be added to it. So here it will display 11. Save. Let us check once. Displays 11. Because there is no difference between pre-increment and post-increment in one statement if you perform only one operation. Now similarly I will write here p plus plus. Printf p equal to percentage u slash n comma p. Save this program. Now can you guess the output? A plus plus means 1 is added to it. P plus plus. Now what will be the output for this program? Generally most of the students will answer, or first time listeners, 1001. So 1001 is the wrong answer. 1001 is not the right answer. So what is the correct answer? So if you increment a pointer variable, what happens here is, so pointer variable, if you increment, it will not increment by 1, it will point to the next location. Pointer variable, it will point to the next location. So this is which type of variable? Integer variable. How many bytes it will occupy? 4 bytes it will occupy. So if you increment pointer, it will point to next location. Next location will be after 4 bytes. So the answer here is 1004. So the answer here is 1004. So here it should be 1004, because if you increment a pointer, it will point to the next location. Now let us see the program. Save. Let me run this program. It is increasing by 572, 576. After p plus plus, its value is 576 because it points to the next location. As it is a integer variable, it has incremented by 4 bytes. Suppose if the variable is of type double variable, double pointer, then for double, what is the format specifier? Percentage LF. Address same, LF. Now double variable, how many bytes it will occupy? Double will occupy 8 bytes of memory. Double will occupy 8 bytes of memory. So if we increment a double pointer, it will point to the next location. Next location will be after how many bytes? 8 bytes. So double pointer increases by 8. You can see the output here. So 568, 576. The difference is 8. That is what we can say here. If you increment a normal variable, it increases by 1. Whereas if you increment a pointer variable, it will point to the next location. So we can say that integer pointer increments by 4, double pointer increments by 8. If you take character and test it, it will increase by 1 byte. And float pointer increments by 4. Okay, I hope you understood this concept. This is very important in pointers. Now let us see the next concept, that is how many bytes the pointer will occupy. How many bytes of memory the pointer variable will occupy. Now let us see how to see how many bytes this variable will occupy. So here we need to size of operator, use size of int star, that is integer pointer, equal to percentage d slash n comma size of int. So size of int, how many bytes this integer pointer will occupy? Save. Now integer pointer, character pointer, float pointer, and double pointer. Let us take. So int star, char star, float star, and double star. So here size of int star, size of char star, size of float star, and size of double star. So here, as I am using a 64-bit system, so here it will occupy, every pointer will occupy 8 bytes of memory. That is integer pointer, character pointer, float pointer, and double pointer. Every pointer occupies 8 bytes of memory. You can see here size of, then close this part. So save, compile, and run the program. That is, every pointer is occupying 8 bytes of memory. Why it will occupy 8 bytes? Because it will store the address, and address is always a numeric value. Now if you observe here, for every pointer I am using percentage d, even though it is a character, float, or double, percentage, because the result what we are going to get is integer. Okay, now in the next video we will discuss about call by value and call by reference with functions, how we will achieve pointers using inside functions we will discuss. Thank you for watching. Please like, share, and subscribe if you have not yet subscribed.